Okay, this time looking at the powers of I. Remember that I is the square root of -1, so therefore I squared is -1. I'll just draw the Argand diagram again. We've got the imaginary axis and the y-axis and the real axis. Imaginary axis is all the values of I, and the real numbers all lie along the x-axis. To first look at I to the power of 0, well, anything to the power of 0 is of course 1. So I to the power of 0 is the same as 7 to the power of 0, or 3 to the power of 0, or x to the power of 0. It's all equal to 1. So I'll just plot that here on our Argand diagram. I to the power of 1 is I, so I can plot that on. I squared is square root of -1 squared, which is -1, so that goes here on the diagram. And I to the power of 3, well, a quick note, you remember of course that 2 to the power of 6, well 6 is 3 plus 3, so we can write that as 2 to the power of 3 plus 3. And the exponent rules state that anything to the power of a plus b can be written split up as x to the power of a times x to the power of b. So this means I can write this as 2 to the power of 3 times 2 to the power of 3. 2 to the power of 3 is 8, so this can be written as 8 times 8, which is 64, and you can check that 2 to the power of 6 is in fact 64. So it's just a recap on that rule. Now I'll apply this here, so that can be written as I to the power of 2 plus 1, or I to the power of 2 times I to the power of 1. I to the power of 2 is this bit here, -1. I to the power of 1 is I. So I to the power of 3 can be written as -I. So I just put that one in down here last. Now we'll move on to I to the power of 4. Using the same rule we did just before, the exponent law, that's I to the power of 2 times I to the power of 2, which is -1 times -1, which is 1. So I to the power of 4 is the same as I to the power of 0. Following on from that, I to the power of 5 is -I times -1, which is I. So I to the power of 5 is the same as I to the power of 1. And this pattern continues. And I to the power of 8. And I'll just use this one to demonstrate every fourth power it repeats. So I to the power of 4n is always going to be equal to 1. I'll just demonstrate that here again using GeoGebra. If we just animate this, you can see that as n, the power of I goes up. I'll just animate this. We go around the Argand diagram from 1 to I to -1 to -I, and so on. And if we change the power to be powers of 4, so 0, 4, or 8, it stays at 1. So using this property, what we'll do is we'll try and solve, or we'll try and simplify I to the power of anything. I to the power of 97, well, we know I to the power of 96, because I to the power of 96, that's 4n. 96 is the 24th multiple of 4, so that means that I to the power of 96 is going to be 1. So we can write this original question as I to the power of 97 is in fact I to the power of 96 plus 1. So that's I to the power of 96, which is 1 times I. So there we have a shortcut for finding out I to the power of 97 is just I. And we'll just prove that here.